plus c square times j cap plus c divided by under root of a square plus b square plus c square times k cap. Now we also know that a by under root of a square plus b square is equal to L, so we can write it as L times I cap plus this is m, so m times j cap plus this is n, so this would be equal to n times k cap. L, m and n are the direction cosines, so we can also write any vector r as equal to the modulus of vector r into L times I cap plus m times j cap plus n times k cap. So L, m and n are the direction cosines of this vector r. The next concept is angle between two vectors. Now if we say that the direction cosines of two vectors a and b are L1, m1, n1 and L2, m2, n2, then a unit vector a could be written as L1 I cap plus m1 j cap plus n1 k cap, and similarly a unit vector b could be written as L2 I cap plus m2 j cap plus n2 times k cap. Now the dot product of these two unit vectors a and b is equal to the magnitude of unit vector a into the magnitude of unit vector b into cos of theta. Theta is, let us say, the angle between these two vectors a and b. Now also the modulus of unit vector a would be equal to 1 because this is a unit vector, and similarly this would be equal to 1. So we can write cos theta equal to a dot b. Now when we take the dot product of these two vectors, we get as equal to L1 L2 plus m1 m2 plus n1 n2. Thus the cosine of the angle between these two vectors a and b is equal to L1 L2 plus m1 m2 plus n1 n2, where L1 L2 m1 m2 and n1 n2 are the direction cosines of these two vectors a and b. Now if a1 b1 c1 and a2 b2 c2 are the direction ratios of two lines, then the angle between these two lines is given by cos theta equal to the modulus of a1 a2 plus b1 b2 plus c1 c2 divided by under root of a1 square plus b1 square plus c1 square into under root of a2 square plus b2 square plus c2 square. Now simply if we put the value of L1 equal to a1 by under root of a1 square plus b1 square plus c1 square and so on, we get this formula. Thus the cosine of the angle between any two vectors a and b given the direction ratios is equal to modulus of a1 a2 plus b1 b2 plus c1 c2 divided by under root of a1 square plus b1 square plus c1 square into under root of a2 square plus b2 square plus c2 square. Now straight lines. Now we know that we can determine the equation of a straight line if its direction is known and any of its point is known, or if we know any 2 points on this line. Now first let's try to find out the vector equation of any line passing through a given point and parallel to a given vector. Let us say that AP is the required line. Now given any point A on this line, the position vector of this point A with respect to O is A. So the vector OA would be equal to vector A. Similarly, let us say that any point P on this line is represented by the vector R. Here R is the position vector of this point P with respect to O. Now we construct this triangle. Also we have been given that this line is parallel to a given vector. Let us say that this given vector is vector B. So this is the direction of vector B, and similarly this would be the direction of vector AP. Now as AP and this vector B are parallel to each other, therefore we can say that AP would be some multiple of this vector B. Thus AP is lambda times P. So from the triangle law of addition, we see that vector R is equal to vector A plus lambda times vector B. So this becomes the general vector equation of any line passing through a point A and parallel to a vector P. Thus R equal to A plus lambda times P represents the equation of line that passes through the point A and it is parallel to the vector B. Now let's try to convert this form to the Cartesian form. So if we say that x1, y1, z1 is the point through which a line passes and it is parallel to a line with the direction ratios A, B, C. Now if we have been given the direction ratios, it means that we have been given the direction of any particular line. So if we say that this is the required line, A is any point through which the line passes, let us say that the coordinates of which are x1, y1, z1. And we have another line which is parallel to this yellow line, and the direction ratios of this line are a, b, c. Then the equation of this yellow line would be x minus x1 divided by a equal to y minus y1 divided by b, that would be equal to z minus z1 by c. Now why this is? Because the direction ratios of the segment AP would be x minus x1, y minus y1 and z minus z1, and these two lines are parallel to each other. So the direction ratios of this line would be proportional to the direction ratios of this line. Thus x minus x1 by a would be equal to y minus y1 by b, and that would be equal to z minus z1 by c. The next is vector equation of a line passing through 2 points. Now earlier we have the condition that the line passes through a point and is parallel to a given line. Now let's try to find out the vector equation of a line passing through 2 points. Let us say that this is the line. Now A is any point through which the line passes. Let us say that the position vector of this point A is vector A. Similarly, this line passes through the point B. Let us say that the position vector of this point B is vector B. This is vector A and this is vector B. Now let's take any point on this line. So the position vector of this point P would be R. Now the vector AB would be vector B minus vector A. Also AP is the extended version of this line AB. Thus AP would be lambda times vector B minus vector A. Thus first of all we can say that OA plus AP is equal to OP. OA is nothing but vector A, OP is vector R, and AP is lambda times B minus A. Thus we can write OP vector as equal to vector A plus lambda times vector B minus A. Thus vector R is equal to vector A plus lambda times vector B minus A. So this is the equation of a line which passes through the point A with the position vector as vector A and through the point B with the position vector as vector B. Now let's try to convert this vector form to the Cartesian form. Let us say that this is the required line. This is the point A with the coordinates as x1, y1, z1. This is the point B with the coordinates x2, y2, z2. And let us say that any point P on this line is x, y, z. Now the direction ratios of AB would be x2 minus x1, y2 minus y1 and z2 minus z1. Similarly, the direction ratios of AP would be x minus x1, y minus y1 and z minus z1. Now these are nothing but the extended versions of the same line. So the direction ratios would be proportional to each other, and hence x minus x1 by x2 minus x1 is equal to y minus y1 by y2 minus y1, which is equal to z minus z1 divided by z2 minus z1. So this represents the equation of line which passes through the points x1, y1, z1 and x2, y2, z2. Now let's try to find out the angle between any two lines. So in the vector form, let us say that the equation of two lines are vector R equal to vector A plus lambda times vector B, and another equation is vector R equal to vector A dash plus mu times vector B dash. So these are the two equations of two different lines, and we have to find the angle between these two lines. Now the angle between these two lines is given by cos theta equal to vector B dot vector B dash divided by modulus of vector B into modulus of vector B dash. Thus the angle between these two lines is given by the cosine of theta equal to the dot product of B and B dash divided by the modulus of vector B into the modulus of vector B dash. So converting this to Cartesian form, let us say that the two lines are x minus x1 by a1 equal to y minus y1 by b1 equal to z minus z1 by c1. This is the equation of first line, and the equation of second line is x minus x2 by a2 equal to y minus y2 by b2 equal to z minus z2 by c2. So for the first line, a1, b1 and c1 represent the direction ratios for this line, and similarly for this line a2, b2 and c2 represent the direction ratios. Now vector B could be written as equal to a1 I cap plus b1 j cap plus c1 k cap, and vector B dash could be written as a2 I cap plus b2 j cap plus c2 k cap. This is because these represent the direction of this line, and in the previous case, that is the vector case, vector B represented the direction of first line and vector B dash represented the direction of the second line. Now cos theta is equal to vector B dot vector B dash divided by the magnitude of vector B into the magnitude of vector B dash. So this is equal to we take the dot product of these two vectors to get a1 a2 plus b1 b2 plus c1 c2 divided by modulus of this. The magnitude of this vector is under root of a1 square plus b1 square plus c1 square, and the modulus of vector b dash is equal to under root of a2 square plus b2 square plus c2 square. Thus, if we have any two lines with the direction ratios as a1 b1 c1 and a2 b2 c2, then the angle between these two lines is given by cos theta equal to a1 a2 plus b1 b2 plus c1 c2 divided by under root of a1 square plus b1 square plus c1 square into under root of a2 square plus b2 square plus c2 square. Now if we say that the lines are perpendicular to each other, then theta would be equal to 90 degree, and hence cos theta is equal to 0. So a1 a2 plus b1 b2 plus c1 c2 is equal to 0. Thus, for two perpendicular lines, we have the condition that a1 a2 plus b1 b2 plus c1 c2 equal to 0, where a1 b1 c1 and a2 b2 c2 represent the direction ratios of these two lines. Similarly, if we say that the lines are parallel, then vector b would be equal to lambda times vector b dash, and so a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Thus, the direction ratios are proportional to each other if the lines are parallel. Once again, if the lines are perpendicular to each other, then a1 a2 plus b1 b2 plus c1 c2 is equal to 0, and if the lines are parallel to each other, then the direction ratios are proportional to each other, or a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Now, the distance of a point from a line. Now, let us say that the equation of any line is x minus x1 by a equal to y minus y1 by b equal to z minus z1 by c. So, let us say that this is the line. It passes through the point x1, y1, z1. Let us say that this is the point A. Now, we have to find the distance of the point P from this line. Let us say that the coordinates of this point P are alpha, beta and gamma. Now, we have to find the distance PL. Now, let us say that L is any point on this line. So, the coordinates of this point L would be equal to lambda times A plus x1, lambda times b plus y1 and lambda times c plus z1. This is because let us say that this is equal to lambda. So x would be equal to lambda times a plus x1. Similarly, y would be equal to lambda times b plus y1 and z coordinate would be equal to lambda times c plus z1. So this is the general coordinates of any point on this line. Now also we see that PL is perpendicular to this line. Also the direction ratios of PL would be lambda times a plus x1 minus alpha, lambda times b plus y1 minus beta and lambda times c plus z1 minus gamma. So these are the direction ratios of this line segment PL. Also PL is perpendicular to this line. So a1 a2 plus b1 b2 plus c1 c2 is equal to 0, and hence a times lambda a plus x1 minus alpha plus b times lambda b plus y1 minus b plus c times lambda c plus z1 minus gamma is equal to 0. And so from this we get the value of lambda equal to a times alpha minus x1 plus b times beta minus y1 plus c times gamma minus z1 whole divided by a square plus b square plus c square. Thus from this we get the value of lambda equal to this expression, and when we put the value of lambda over here we get the coordinates of point L. Now using the distance formula we can find out the value of the length PL. Thus to calculate the distance of any point from a line, consider any point L on this line. Now find out the direction ratios of this segment, and using the expression a1 a2 plus b1 b2 plus c1 c2 equal to 0 for two perpendicular lines we get the value of lambda. Once we have known the value of lambda, we calculate the value of the coordinate.